Graph the following functions using your knowledge of the parent functions and transformation rules. List the transformations above the graph for each step. You may not need to use all graphs for all problems. Well, first of all, we need to identify what's going on here. And I am going to do this in 3 steps, but you can graph it in 1. Don't forget to put the transformations, however. This 2, outside of the function, means that we're going to vertical stretch the graph by 2. The minus 2 inside the function means that we're going to move our graph right 2. And the minus 1 means that we're going to move our graph down 1. So when we take a look at our parent function over here, we're still going to start at 0, 0. But instead of going 1 space to the right and 1 up, which is coming from the parent function, we're going to go 1 space to the right and 2 up. 1 times 2. Instead of going 2 spaces to the right and 4 up, we're going to go 2 spaces to the right, and we're going to go 4 times 2 up. So we're going to go 8 up. And the thing is, if we do that on the right side of the graph, then we can do that on the left side. 1 space to the right and 2 up, and 1 space to the left and 2 up, 2 spaces to the left and 8 up. So there is our vertical stretch. And then we're going to take that graph and we're going to move it right 2. So we're just moving every point over 2 spaces to the right. And then we're going to move our graph down 1. So down 1 here. We're moving every point down 1. But here's our final graph. And now that we've got our graph, what we want to finish with is the domain and the range. Our domain is all real numbers. Our range is not. We ask ourselves, do we have a high point or do we have a low point on the graph? We have a low point at -1. And we're going to continue upward forever, which is going to infinity. Same idea on problem number 25. Negative in front of the function means that we're going to reflect the graph over the x-axis. That is outside of the function. Plus 6 inside the function means that we're going to move our graph left 6. And the plus 3 means we're going to move our graph up 3. So start by reflecting. This graph is going to turn over. So instead of going 1 space to the right and 1 up, we're going to go 1 space to the right and 1 down. 2 spaces to the right and 4 down instead of 4 up. 1 space to the left, 1 down. 2 spaces to the left, 4 down. There's our reflect. And then we're just going to move our graph left 6. So nothing's going to change except that we move it here. So the pattern of the graph, 1 space to the right and 1 down, 2 spaces to the right and 4 down, 1 space to the left and 1 down, 2 spaces to the left and 4 down. That does not change. And then we're going to move that graph up 3. Again, the pattern of the graph is not going to change. So here is that. Just moving every single point that we've got in our graph up 3 spaces. And again, you can do that in 1, but after we get those done, then we need to come up with the domain and the range. And not much thought goes into the domain. But our range this time, do we have a high point or do we have a low point on the graph? And this time we have a high point. So we're starting down here and we're moving up. So we're going to start at negative infinity because the range are the y values, and we're going to go up to the y value of this point, which is 3, and it is a point on the graph, so it is included.